Greetings. Today we are looking at the SR-71 with a top speed of Mach 3.2, and then we're going to be looking at a space shuttle.
Really? Well, that sounds pretty good.
Some facts about the SR-71 with a top speed of Mach 3.2. It actually could go faster than Mach 3.2. It has the ability, but the plane will come apart. The back end of that gets up to 649 degrees Celsius, and it requires a special black paint, and it uses a astro-inertial navigation system that uses the stars to calculate its positions. And one of the main abilities to achieving these speeds is because of the ramjet system, and you can research a little bit more on that if you want to. And the ramjet system actually would allow the jet to go up to Mach 5, but like I said, it gets too hot and there's too many other problems for the jet. It constantly expands and contracts as it flies at its Mach 3.2. It does leak fuel on the runway constantly. It constantly needs maintenance and new sealants applied because of the expanding and contraction during flight. It has to have a special fuel tank, again, because of just so much going on at that speed, so much expanding and contracting. So, interesting stuff. So now I want to take a look at the Space Shuttle Discovery STS-133. I looked at several different Space Shuttle flights and launches, and the STS-133 is just the one that I landed on. And there's some things about it that just doesn't seem to make sense to me. And so we're going to take a look at that. So again, this is STS-133. And one thing that I remember when I was a kid, I noticed this, and it really freaked me out. This looks like a bouncing effect on takeoff. You know, how much throttle control do they have to have so that it doesn't come crashing back down into the launch pad? It looks like it would make me very nervous. Let's take a look at this.
Go for main engine. Go for main engine start. We have main engine start. 2, 1. Booster ignition and the final liftoff of Discovery. A tribute to the dedication, hard work, and pride of America's Space Shuttle team. The shuttle has cleared the tower.
Now rolling over onto its back with a 10-minute ride into orbit. Discovery now making one last.
Okay, here, so I did some research, and for this to get into low Earth orbit, and it requires a speed of Mach 23 point something, basically Mach 24, and this launch, after 8 minutes from launch, it hits Mach 24, and I'm wondering how these brackets stay intact. How do they not become just shredded? And all these other little things like this down here on the tank, you know, how does this not become shredded? And I didn't realize this until I was researching, making this video, how much NASA and this is NASA footage here directly from NASA, but how much
reach the stars.
They just zoom in. And I wanted a perspective where they don't, you know, what's this look like from the ground? And I had to go, and I'll show it here in a little bit, I had to go find amateur footage. Otherwise, there was none. No, there was no professional footage that I could find where they just showed what it looked like from the ground. So let's keep taking a look at this here.
Reducing the stress on.
Trying to speed it up. This is what I'm talking
Discovery
about.
Houston, you are go at throttle up.
This is about 2 minutes into the flight. anyway, it just keeps going on like this, where they show the close-up. It's hard to see, you know, the ability to use your senses to see how far downrange it is. But something to keep in mind is 8 minutes into the flight, Mach 24. And so I want to now take a look at some amateur footage. So this is some amateur footage that I found, and I found several. This is the same flight, by the way, the STS-133. I made sure everything was the same. So this is about 2 minutes long, and I'm not going to play the whole thing, but you get the idea of what I'm talking about. When this takes off, and I watched this side by side with the NASA footage, but just zooms in, you know, after, like I said, when you get into 8 minutes, you're at Mach 24, and you know, 2.5 minutes, I mean, it's pretty ridiculous, Mach 6 or 7 or somewhere in there. I mean, you can see it for yourself. But my criticism is, you know, after 2.5 minutes, that thing should be so far gone, and it's just right there. If I was just to look at it and use my senses, I would say, you know, it's going 600 miles an hour maybe. And if it wasn't for the little gauge that NASA provides showing, oh no, you know, we're hitting Mach 10 right now, no way. Looking at the amateur footage, I don't mean to sound so critical, but just using my senses, I would say there's no way that's hitting these speeds if it wasn't for this little gauge telling me. Let's just watch a little bit of this here.